Let's go ahead and try a circle with a tangent line problem together. So we're told that segment UV is going to be tangent to circle W. So if you look at segment UV here, what they're really trying to also tell you with that information is that we do have a right angle at this location. They intersect at point U, so that's going to be this location where the circle is touching that segment of UV. And they're asking us what's the value of X. So you can see we have the variable X located in a couple locations here. All right, so right off the bat, a key part of understanding how to solve this problem is understanding that this is indeed a right triangle, so that's going to be really, really important. And so if we go ahead and look at this right triangle on the side here, we do know that one of the legs is going to be this expression of 2x minus 4. And we also know that one of the other legs here is going to be x minus 1. So we do have those two legs. Now the next part of this is where some people get a little tripped up here, but keep in mind that this WU segment is the radius. So that also means that this WZ segment over here is also going to be the radius. So we can go ahead and say that this segment from W to Z at least is going to be x minus 1. And so when you go ahead and take a look at this entire hypotenuse of this right triangle, keep in mind that you have to take a look at this piece of x minus 1, which is from here to here, or that radius, and you have to add on this 2 over here, which is the extra part of that segment from Z to V, right? So if you go ahead and add this x minus 1 and you add 2 to that, that really becomes x plus 1. So that's going to be the hypotenuse of this right triangle. Now setting up an equation using those segments, we can say that segment WU squared, or one of the legs squared, plus segment UV squared, that's that other leg, we're going to get this segment of WV to the second power. So that's going to be our general equation here, right? If you go ahead and substitute some values in, we know that WU is going to be this binomial of x minus 1 squared. Plus you have this other binomial of UV, that's going to be the quantity of this 2x minus 4, that whole thing squared, and is going to be equal to WV squared, and we said that was going to be this x plus 1 raised to the second power. Now if we go ahead and expand this binomial, we're going to end up with x squared, and then it's going to be minus 2x, and it's going to be plus 1. So if you need to pause to go ahead and FOIL that out or distribute it out, feel free to go ahead and do that. Now for this next part here, if we go ahead and multiply this out, this is going to be 4x squared, and then I believe it's going to be minus 16x, and then this minus 4 squared is going to be plus 16 here. Now just for the sake of space here, I'm going to move this up so we have a little bit more space. And if we go ahead and expand this binomial squared over here on the right side, we're going to have x squared plus 2x plus 1. And of course, if you need to pause the video to go ahead and multiply those out just to double check, feel free to go ahead and do that to make sure all that algebra makes sense. All right, next let's go ahead and just combine some like terms here. So combining these, we're going to get 5x squared. Then combining our x terms here, we're going to get minus 18x. Then for our constants here, we're going to have plus 17. And on the right side, we're still going to have this equal to x squared plus 2x plus 1. Next, if we go ahead and take away x squared from both sides, we're going to end up with 4x squared on the left side of the equation. Then if we go ahead and take away 2x from both sides, we're going to get minus 20x on the left side of the equation. And then if we go ahead and take away 1 from both sides, we're going to get a positive 16 on the left side of the equation, and this is going to be equal to 0. So keep in mind that when we have quadratic equations, we like setting it equal to 0, because then we can go ahead and maybe see if we can factor, or maybe we'll use the quadratic formula or completing the square or something like that. Next, I'm just actually going to go ahead and divide by the GCF. So it looks like we can divide everything by 4 here. If we go ahead and do that, we could factor out the 4, then divide both sides by it. But I'm just going to go ahead and divide everything by 4 here. We're going to get x squared, and then minus 5x, and then plus 4, and that's going to be equal to 0. Now, I like always checking to see if I can factor first. I think you can here. I think this factors nicely into x minus 4 as well as x minus 1. So if you go ahead and multiply that back out, you should get what we just kind of had just a moment ago. And if you go ahead and use that zero product property here, in order for this equation to be true, x would have to be either positive 4 or x would have to be equal to positive 1. Now, while we do have two solutions here of x equals 4 and x equals 1, those are our algebraic solutions, we should check for extraneous solutions and see which one maybe makes more sense in this context. If you take this 4 here and you plug it into our triangle, I guess, right? If you go ahead and look back up at our triangle, if you go ahead and plug in 4 into this expression, we're going to end up with 3 for this leg. If you plug in 4 over here, 2 times 4 is 8, minus 4 is just going to be 4. And if you go ahead and plug in 4 over here, 4 plus 1 is going to be 5. So we're looking at a 3, 4, 5 triangle, which is a Pythagorean triple, so that does make sense. So we should feel that x equals 4 does make a lot of sense. But how about this x equals 1? Well, if you plug in x equals 1 over here, we would get a side length of 0, and that doesn't make any sense. How could we have a triangle over here that would also over here have a length of -2 over here? And then over here for our last dimension here, this would be +2. So if you're going to take a look at this when x equals 1, well, obviously it worked algebraically to get this solution here, but as an actual answer for this application, it doesn't make sense. So for our solution, let's just go ahead and make sure we say that x is going to be equal to 4 to make this whole thing true. Make sure you don't use this x equals 1. So that's how we would go ahead and apply our understanding of circles and tangent lines to go ahead and solve a problem like this. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.